The first talk in our program is going to be held by the fabulous Mathilde Berchon, who is currently with the Future Lab in Paris. And she is going to take us on a little reflection. Whatever happened to that home factory we were promised and the 3D printer in our houses? Why is it not there yet? And when is it coming? So about the future of 3D printing and where we're at with it today. Over to you, Mathilde.
Hi everyone, hi, welcome, thanks for connecting. I'm super happy to be here with you. My name is Mathilde Berchon. I've been involved in the maker movement, 3D printing for about 10 years. I actually have wrote a few books in French about 3D printing and work for multiple startups, maker spaces, companies that are involved in this movement as well. So super happy to be here. The goal of this talk is really to tell you more about 3D printing and mostly really go through the phases of the 3D printing movement, because I think we are really entering a phase that's super interesting and that could really inspire you to get going with these technologies. So actually, how did I get involved with this movement? It all started with a big dream. I always, as a teenager, I really dreamed of living in San Francisco. And so I actually moved there from Europe to Silicon Valley in the year about 2010. And I really discovered something that was amazing there. That was this explosion of maker culture. So there was spaces like hacker spaces, there were maker spaces with, or fab labs with, so actual places where people would meet, share tools, share machines, and share knowledge, and teach each other, learn from each other by documenting projects and by just sharing the inspiration around making things. And so that's really a movement that's based on empowerment. As you might know, the idea is that if you give tools to somebody, they can learn and they can actually start to untangle, understand the world differently. And that's really what I think is super inspiring in this whole movement. And that's really also what made 3D printing specifically like a symbol for a new alternative world that we could create together. So the idea is really to give the tools and the knowledge to anybody who wants to understand how the world works. So the products around us usually are kind of like black boxes. We don't really know where the products come, how they are made, which materials they are made of. We can't even really open most of the products around us. They are sealed, right? And when you open them, you can't really have access to the way they are made. Like, it's something that is not easily shared. And it's also something that makes us not be very able to repair, to fix what's broken. And when it's broken, usually we end up buying a new product or replacing it because, well, it's too complicated. We don't know how to fix it. So the idea of the maker movement was really to completely change this and finally give access to citizens to machines, so they can actually make products themselves, modify products, adapt the products around us so they are more usable and fitting our needs, and also being able to open those black boxes and understand how they work, to be able to open up the world and give back the power finally to citizens. So to go from being passive consumers to actual active members of society that can actually have an impact on the world around us. So that was really the promises of the maker movement, and I think it also came from having access to new tools, to new machines. And 3D printers really came at a time where there was this desire. It was really a meeting point where there was this desire to understand better the world around us, and those tools were giving us these opportunities. So in the year 2010 to 2014, it's really a specific moment in time. It's a moment where 3D printing became suddenly a technology that was available for anybody. Before that, actually, 3D printing, as you might know, was started in the 80s. The first 3D printer was actually sold in 1988. So it's a technology that existed for a long time, and that was mostly used by industries for prototyping. So it was machines that were pretty big and that were used by experts, by people who knew what they were doing, and it was really the beginning of the 3D printing was mostly used for prototypes. Very functional, realistic prototypes, but that was it. And so in the year 2009, one of the patents around 3D printing expired. The FDM, Fused Deposition Modeling patent, expired. And so that opened up possibilities for a lot of those makers that were hanging out in hackerspaces, in makerspaces, to actually start tinkering. Finally, there were some technologies that were open and available to actually being modified. And so what started as an academic project in the UK, in the University of Bath, by Adrian Bauder and his team, became, so they decided to open up the machines, to make them open source, and to share the plans online. So everybody who would want to create their own printer, build their own machine, was able to do it with one rule, which is to be in open source hardware, right? To document how you do it, to reshare the information online for other makers to build up upon you. So that was the idea. And so because we were at a time where there was this strong, these spaces that were starting, there was also online platforms that were there. Everything was in place. And so all the people around the world, like tons of makers, started to download the files and make their own printers. And so that's really what suddenly gave rise to this 3D printing as a symbol, as a potential machine that could really completely revolutionize the world and the way we make it. And so a lot of makers started to team up together to start their own companies. So for example, at the time, there was MakerBot that was one of the strong visionary behind the movement with the idea that everybody is going to buy a printer. It's going to be a bit like a computer or a phone. We're all going to have one at home, and we'll be able to print easily anything we want just by the push of a button. So that was a bit the message that was sent around that time. So tons of hopes, right, of promises. You might be familiar with a famous curve called the Gartner hype cycle. So it's really like usually almost all innovations go through those phases. So there is this moment of high expectations where everybody is a strong believer that it's going to change the world, it's going to be amazing. And so a lot of people get excited, enthusiastic about the technology and start companies, start projects, start to use the actual technologies. And then there is a huge crash. And so that's exactly what happened for 3D printing. Around the year 2015, something like this, for 3 to 4 years, it was this big crash where actually the users, the first pioneers, right, that started buying printers thinking, oh, they could use it, actually had a bit of a reality check. Because maybe you're familiar with this, but of course, if you buy a printer, you will realize quickly that it's not so easy. You are pretty limited if you don't know modeling software, if you don't know how to scan something and then modify it. Like, you need to be pretty techy to be able to actually get good results with your 3D printers. Even if there were more and more 3D printers being more easy to use, etc. Like, it's still something that takes some work. It's not so easy. So plug and play. So that's what happened. There was a bit of a reality check, really, of okay, what am I actually going to do with this printer? So a lot of printers actually stayed in closets and were not used so much. But what happened is that during that time, a lot of the actors, of people working in 3D printing, kept working on 3D printing. We're not so following, the media bubble around the technology. And so those people, that there's this foundational team maker community that has kept working with 3D printing, also in industries, right? Like, a lot of companies got equipped with 3D printers at the time. Many of them didn't really make use of it, but a bunch of them, a good niche of them, actually kept working hard to learn the technology and see what they can actually do with it. And those foundational practices actually are really right now. You can see that we are entering a new phase, like since 2018, something like this. We are really back like on a much more realistic approach around 3D printing. So we are not talking as much about you know, like a disruptive revolution that, you know, from one day you do things this way, the other day you actually 3D print everything. Of course not. That's not the way it is. The expectations are much more realistic now. And so that we are really entering a phase of actual growth. The movement is continually growing, but with people who are much more knowledgeable about the technology and are actually able to see the potential as they are. So what we see now is, first of all, one myth that got bursted is the idea that, okay, there was the idea that 3D printing is going to replace everything. That's not going to happen, right? Like what happened, what we see now in the way people are using 3D printing is that it's more like an additional technology that you combine with other technology. So for example, in industry, additive manufacturing is definitely a game changer. But for example, it's a game changer for tooling. So you can actually 3D print molds in a much more efficient way, thanks to the arrival of metal 3D printing. You can actually print tooling. So conventional processes and 3D printing are hand in hand, really. They work together. And so we are really improving the way we make things with use of less resources, optimization of shape. Like you can really improve already a lot of the conventional processes thanks to additive manufacturing. So that's one step. Like now we are more aware that, okay, 3D printing is linked to it's part of a big ensemble of processes. The second thing is that we now have a very strong awareness of a specific field called design for additive manufacturing. So what is design for additive manufacturing? It's the understanding that when you create a product for 3D printing, a piece for 3D printing, it needs to be designed a certain way. Like there is specialties around 3D printing that you don't find with other processes. And so that's something that is a big challenge nowadays, is that a lot of engineers, designers have been trained in school with conventional processes, and they had to learn a new way. Because when you design for 3D printing, for additive manufacturing is the same word, when you design for 3D printing, you need to sync the parts differently. For example, consolidation. In the conventional processes, usually when you design a part, you need a lot of different parts because even if the part is complex, you will need to create the different parts and then assemble them. So one complex industrial piece, like a engine, like turbine, or any part really is made from many other parts that are assembled together. With 3D printing, you can completely change completely this design. You can actually print directly a complex part. So you can have a part that has, internal cooling system. You can have a part that has moving modular parts inside it. You can decide that you're going to put a more dense material on one part and less on this part. You can remove a lot of material that you use by having very organic shapes. So all these things around design for additive manufacturing really completely require a change of mentality. You really change your mindset. You have to really learn the specificities of 3D printing to be able to really design parts. And that's also a reason, I would say, why there was this big kind of deception, like where the makers started, like something that we see a lot on Thingiverse, for example, like the platform where people share 3D printed files, is that you see a lot of files that are available, but they are actually just a copy of an existing product. So for example, I see a lot of boxes for, Raspberry Pi or anywhere, like boxes. 3D printing is not good at printing large flat surfaces like a box. This is designed for injection molding processes. right? Like a lot of the world around us is made of squares, of boxes, because that's the way the machine works. That's how it shaped our world. And 3D printing can shape a completely different world. When you don't need to think inside a box, you can really rethink the way you design parts in a much more organic way, maybe with a better cooling system. You don't need to put material as much as before. So like that, there is still, I would say, even more in the maker community, like really a need for rethinking the parts for 3D printing. Another interesting part, I would say, is distributed manufacturing. With the COVID pandemic, like we saw, as you all, I'm sure, followed, like the actual amazing experiment, giant world experiment around distributed manufacturing, where makers from all across the world started to want to help out at the beginning of the pandemic and try to find solutions and how to help out. And 3D printing became this very useful tool where locally you could produce parts and you can send your designs, improve the design on each other, and actually print part locally to be able to help local health professionals, for example. So you saw like the face shield, things like that. Again, that was for the first time in history like a giant trial at doing distributed manufacturing. And what we saw, like tons of learning came from this, and I think it was a brilliant prototype of what could come next. For example, the idea of quality control, because if everybody is printing in their local makerspace, like how do you make sure the part is actually compliant for health purposes, even more in that specific case. So quality control was a big one. Also, how do you actually also relocalize material, access to materials, like that was something that was instantly a complexity. But what we saw is that there is today like a potential backbone of local manufacturers that could be able to produce locally. I would say one thing is that there is often a mix between what a desktop 3D printer like the one behind me can do, and usually what is the type of printers that makers have, which is really designed for prototyping, and what actual industries can do. Like when you see additive manufacturing technologies, you can actually print super complex parts made of metal that are used in planes nowadays. So there is often a confusion between what can 3D printing do and what we actually, us as citizens, have access to. So that's something also to consider. And so we saw the rise, for example, of manufacturing platforms like hubs, for example, that is really exploding. This idea of distributed manufacturing with industrial capabilities. So those are things that we are going to see more and more in the future, I would say. The design for additive manufacturing parts. So there is a huge need. I also want to take this opportunity to do a call really for makers, like to start really thinking, what could I do with additive manufacturing? There is a lot of possibilities with applications with 3D printing that are really never seen before. And I think instead of focusing on actual equipment, like the printers, like I think it's a terrible idea today to create a new 3D printer. Or like there is all, like the infrastructure is there now, like the actors are pro, like they are really providing good equipment. I think there is a lot of work to be done on applications. What do we do with these 3D printing possibilities? And that's when there is so much to do. And I think that really could be like a game changer, even more really with questions like climate change, for example. And so we saw it also with this COVID, the distributed network of face shield. There was the first phase of this initiative was to ask yourself, like there was this huge R&D, right, between makers from all over the world to say, okay, we have the machines, we want to help, what do we make? And so there was a lot of proposal, like should we 3D print masks, should we 3D print you know, tools to open doors. Like there was all this big brainstorm of what potential applications we could have that could help. And face shield became kind of the solution, like something that you can 3D print that is certainly helpful. So that's how it came down to face shields. But what about if we do that for everything else? Like the world is filled with products that are made on the other side of the world that consume tons of carbon and that could really be impacted by this. So this work needs to be done not only on the, okay, can we actually produce locally, but also the early phase of the 3D printing, right, which is really designing, thinking of applications that really understand the specificities of 3D printing and that activate that.